Sharing my screen. Good. All right. Last day doing it. I had a request for number 9 from test 2. But also last day I had a request for another ant problem. This doesn't say ant, but we're the ant in this case. And so I'll keep this one up my sleeve. Haven't tried it, so hopefully the numbers are nice. But let's do number 9 from the test. Did you say test 2?
Yeah.
Okay. Let's see here. Where is it? Blah, 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 blah. Number 5, number 6, number 7, number 8. Number 9. Okay. Oh dang, how do I copy this without erasing my solutions? Let's do this. Copy. This is from test number 2. Okay. So what we need to remember is it asks for the vertical asymptotes. It also asks you how to find them, but I'll just ask you what the vertical asymptotes are and what the holes are. So you don't have to explain yourself, but obviously to do it, you need to know what they are. So that's why I put it on there initially. And is this the one you meant?
Yeah.
Yeah. So let's start with the vertical asymptotes versus the holes. Okay. They both have to do with the denominator. Okay. And so the vertical asymptotes are going to happen at values of x that make this equation 0 or dividing by 0. Okay. So at x values where we would divide by 0, we can't, right, by the domain, would divide by 0. Okay. But we see that there are kind of common x minus 2s to the power of 6 and to the power of 2, x minus 4, x to the 7, x to the 10, right? And so what we're going to do is we're going to simplify this first. Okay? And so anything that cancels from the denominator doesn't make a vertical asymptote, but anything left over that doesn't cancel would be a vertical asymptote. For example, let's say that this was just x minus 2 up here, right? X minus 2 divided by x minus 2 squared leaves you x minus 2 in the denominator, right? And so then here, I'll just say, for example, if that wasn't there, right? Just because this one is all holes, as we'll see, if we left it, but let's just have one that's not all holes. X minus 2, and then this one is going to cancel. Why? Because x minus 2 to the power of 1 times, technically, x minus 2 to the negative 2. So this is to the power of 1 is x minus 2 to the 1 plus negative 2, which is x minus 2 to the negative 1, which is the same as 1 over x minus 2. That's technically what we're doing, right? But you're allowed to just look at the powers and say, okay, if I'm dividing powers, right, 1 over 2, then I'm allowed to take away this 1 and subtract 1 from here, right? And then I'm left with just x minus 2 here. Okay. So, good. So in this example, I'm switching it up because we've already seen it. But if we have, let's just focus on 1 over x minus 2. At x equals 2, right? You can set x x minus 2 is equal to 0. That's bad, right? And so if you solve for x, you get x is equal to 2. But usually you can just plug it, you can just see it, right? If it says x minus 2, then you know 2 would make it 0, right? And so here, we would have a vertical asymptote at x equals 2. I'll call this a new example. And we'll do can do a fresh one later. Okay. X minus 4 over x minus 4, 5 minus 3 puts me at 2 in the numerator. So here I get to 2 and 3 goes away, which means that x minus 4 cancels from the denominator, right? So it's no longer a possible vertical asymptote at x equals 4, but it was there originally, so it is still a troublemaker, but it makes a hole instead. So we have a hole at x equals 4. Since it was entirely canceled from the denominator. Since it was canceled entirely from the denominator. By the same logic then, right? X minus 7 to the power of 4 times, or divided by x minus 7 to the 3. Well, 4 minus 3 makes 1. So then I'm left with here, and then this is all going to cancel. Same thing with x minus 10. So that means I have a hole at x equals 7. And finally, same thing here, x minus 10 to the 3 over x minus 10 to the 2. It's kind of a boring one. 3 minus 2 makes 1. So we also have one at x equals 10. Let's make up another one. Not very creative. We'll just do 3. Yeah. Let's see here. Let's do. Whoa, curveball. Curveball. Okay. So first thing you want to do, if you're trying to find the vertical asymptotes, is go through and cancel, and then of course you have to find the holes. And so you're going to go through and you're going to cancel and simplify all the like bases, right? So, and they'll be stacked on top of each other, right? And so that's nice. And so here, x plus 3 to the 2 over x plus 3 to the 5. So now x plus 3 to the 2 is going to go away, and the 5 is going to be at 5 minus 2, right, which is 3. X minus 4 to the 5 over x minus 4 to the 5. If you just focus on that individually, right, then that's just 1. Nice. And so this is just entirely going to cancel out. X plus 14 to the power of 10 over x plus 14 to the power of 9. This 10 minus 9 makes 1. This is going to cancel. And then there's nothing to cancel the x minus 7 to the 3 with. I'm going to change this actually because I want to, no, it's okay. It's okay. Keep it. Okay. So once you've canceled, the ones that are left over in the denominator, right, those can't become 0, right? Because at those values that make it 0, you have a vertical asymptote. And so here, if x is -3, you get a vertical asymptote. And if x is 7, you get a vertical asymptote, right? So here at x equals -3 and x equals 7. I should highlight, make it bigger, -3. The holes will be at, let me just rewrite this here. The holes will be at the values where you would have had a vertical asymptote if you weren't able to cancel it out, right? And so in this case, x equals 4, even though they both cancel to 1, they were there in the original equation, right? And so you have a hole at x equals 4 and at x equals -14. It's all about working those powers and simplifying and remembering that what a vertical asymptote is versus a hole, right? Is that good? Nice. Okay. Any other requests before we do an ant style problem? Ant style. But in this case, we're the ants, or we're the ant, I guess. But any others before I jump in? Okay. Here's an ant style problem. To me, these are the same as an ant problem, right? I know that to you, maybe not until you've kind of worked through it, but the procedure is going to be the same. Okay. So a small radio transmitter broadcasts in a 53-mile radius. If you drive along a straight line from a city 70 miles north of the transmitter to a second city 74 miles east of the transmitter, during how much of the drive will you pick up a signal from the transmitter? We're gonna think about it. Okay, so then I'm going to, I'd say first sketch it out, right? You've got a transmitter with some center. Let's put her there. And these cities are in reference to the center of the transmitter, right? And so that's nice because then I'm gonna have, whoops, I can put my north, my kind of compass here. East, south, west. West can have an arrow too. We've got a 53-mile radius, whoops. And so then this is at 53 and this is at 53, right? And so just in reference to where am I going to start from and where am I going to end, can I didn't want to draw on the question. Let's keep going here. We're just sketching it out, right, to get a general idea. And on the final exam, I'll give you the grid, right? And that should help. But let's say, okay, if this is at 53, because that's can I?
Only if you center it, I guess.
Yeah, so the problem is centered at the origin, whereas the pizza problem, the center is not at the origin, and that's like part of solving it. I guess I could put a circle on there. Wow, I'm nice. To figure out how to program it though. We'll see. We'll see. Okay. So 53-mile radius. So that tells me that this here is at 53. So 70. Let's put 70. I don't know, somewhere up here. So you start 70 miles north and you go to a second city 74 miles east of the transmitter. And so 53, let's say 74 here, right? And the key is that, of course, well, hopefully, wherever I draw my fake points to, let's do that. Let's put 74 here. Because I really, really doubt that a problem is going to ask you to find how long you pick up the signal for if it's none of the time. That seems unlikely. So let's see here. First thing you do, draw it out, right? Draw out the situation. And then however you've interpreted the situation, right? As long as you draw it out the way you interpret it and you follow through with that, then I'm good with that. Okay. So just make sure you draw it out nice and carefully. Let's see here. Let's see if I can draw 25. Maybe a nicer, whoops, a nicer line. Let's put let's put 70 here instead, and 74. Maybe not. That's why I need that grid. There. So, same thing, just kind of a little bit more reasonable. How are you going to approach this problem? So you draw it out, and then we want to figure out this distance, right? That's inside the circle, right? Which is however long that ant has to hold its breath for. It's however long we have radio transmission, right? And so it's the same problem, right? And we want to find this distance. How are we going to do that? You've got a circle and you've got a line, and you need to find the intersections. But in order to find the intersections, you first need to find their individual equations, right? How do you find the equation of a line? Let's start there. If we talk about this as a polar coordinate grid, then we have this is at 0, x is 0, and y is 70, right? And so we can rewrite it as 0, 70. That's a point on this line. And then we're going to 74, 0, right? X is 74 and y is 0. So let's find the equation of the line. I'm hoping, but it doesn't really look like it, but I'm hoping that it'll give me a nice, nice slope. On the final exam, I'll make sure you have a nice slope, no fractions, right? Because that just makes a mess. Okay. You can do it, but it's an added layer of difficulty. And so the equation of a line from 2 points, first thing we need to do is always finding the slope for finding the equation of a line. Now the slope, rise over run, is the change in the y's, y2 minus y1, over the run, x2 minus x1. Which is on your formula sheet in case you lose it. Doesn't matter which one you treat as y1 and y2, but let's do, this is my first point and this is my second point, since this is where I'm starting and this is where I'm ending. But it doesn't matter as long as you're consistent, right? Which point is which, point 1 and point 2. So y2 is 0 minus y1, which is 70, over x2, which was 74, minus x1, which was 0. So the slope is negative 70 over 74. Yuck. Oh, barf. Negative 0.9459459459459. Ugh. Let's use a rounded value just to kind of imitate a nice slope. Okay. And so here, let's do negative 70 divided by 74 again. Here, I get negative 0.9459459. Repeating. Rounding to 3 decimal places. Right. Lob off the repeating. M is negative 0.946. Now we'll just use that. Right. Makes sense that it's negative, right? Because I've got this downward slope, and so I'm expecting a negative slope. Otherwise, forgot to do the 0 minus 70, right? And so that's a good check-in. Does the slope match the line that you drew? Once you have your slope, the equation of the line, y equals mx plus b. Well, now I have the slope m, and I have 2 points to choose from, right? I have 74, 0 and 0, 70. And so whichever one you want to choose, they're both on the line. We're forcing them to be on the line. So it doesn't matter, but let's use 0, 70. So y equals negative 0.946 x plus b at 0, 70. Or, you know what? Nah, I changed my mind. But this is more, I was going to say pedagogical, but andragogical. Pedagogy is when you teach children. Andragogy is when you teach adults. Anyways, andragogical. Why did I choose this one instead? Because we're trying to find b, which is the y-intercept, which should be 70, right? And so let's plug in 74, 0 instead and just make sure that it is 70. We've rounded our slope, right? And so we'll see. But in that case, y is 0 and negative 0.946 times 74 plus b. We're about to find out how big of a difference rounding the slope is going to make. 74 times negative 0.946. Not bad. I get 0 is negative 70.004 plus b. Right. I will make a note here. From our graph, we know b is 70, right? So this is from rounding m. So I'll do something sneaky, right? Solving for b. I'm just gonna use 70. So I carry that 0.004. Let's ignore it. So b is going to be 70. Technically 0.004. Let's do this. Let b be 70. You don't have to show your work for finding b at this point, right? I've got another question making sure that you know how to find the equation of a line. I'm pretty sure we picked one. I'm sure I forced you to pick one of those. And so at this point, if you look at this and you say, okay, I can see that b should be 70, that's fine by me, right? Your goal is to find the equation of the line. Okay, so then y is negative 0.946 x plus 70. That's the equation of this line that we drew. Phase 2. Find the equation of the circle. I'll use find the equation of the line in blue, and then I'll use green for find the equation of the circle. the general equation of the circle, and I posted the updated formula sheet, which includes the circle equations that you'll have. I also gave you the Pythagorean theorem, the distance formula, and finally the equation of a circle. I suspect you'll only need the equation of a circle, but it might be nice to have the others. Mostly because I suspect that you already know the Pythagorean theorem, but if you're blanking. And so the equation of a circle centered, this is important, centered at HK, right? Those are for those questions where we're not centered at the origin. In our case, H and K, we force them to be 0 because that makes our problem easier, right? And we did the same thing with the ant problem, okay? And so here, H is 0, K is 0, and the radius was 53. So we've got x minus h squared, whoops, plus y minus k squared is equal to r squared. In our situation, we have x minus 0 squared. You don't need to show this, but I want to highlight that h and k are both 0 is 53 squared. $53 squared, it's got to be huge. It is 2809. So then we have x squared plus y squared is, let's not carry that square around, 2809. And that's the equation of our circle. We can leave it there. You can solve for the y's if you want, but we're gonna do that later anyways, so I would just leave it there. Okay. So now you know mathematically what the circle has for an equation and what the line has for an equation. What's the next thing we want to do? We want to find these intersections, right? And so now the intersections happen when the line and the circle equations are equal to each other, right? They have the same xy point here and the same xy point here, right? And so we're going to find 2 points, right? How are we going to get 2 points out of this? Well, let's see. So phase 3, I guess. And I'll underline this. Sorry, I'm gonna do a thing that's kind of bothering me because I'm gonna change this to green. It's subtle. But now the green stuff is for the circle, the light blue stuff is for the line, and the pink stuff will be for the intersections. Find the 2 points of intersection. Right, we need those points to find the distance between the two. Right? So find the points of intersection. What do? That's where the circle, oops, should use the same colors, is the same as the line. Okay. Now, a couple of different ways you could solve it. You could take the line equation, which is already set to y. You could solve for y in the circle equation if you want, and then set them equal to each other. Or another way that you could do it is you could plug in this value of y in here, which is how I think we did it before, right? But you could solve for y here And that might be fun. Should we do that? Do you want to stick with the same method that we were using, or do you want to see kind of multiple methods? Same method. You got it. And so, okay, then x squared plus y squared is 2809. But at y, I know, but good. Negative 0.946x plus 70. Now, when I plug it in, I'll do pink. So now I get x squared plus, and you got to have brackets around this y now because it's the entire thing, the entire line is squared. So negative 0.946x plus 70 squared is 2809. Once we expand this, we see we're going to get a quadratic, which is nice because we know how to deal with quadratics and we know how to solve for x in a quadratic set equal to 0. So we're so close, we can taste it here. Let's expand this thing. X squared plus, I always have to write out the negative 0.94x, 6x plus 70 times negative 0.946x plus 70. If you can just see it, then that's cool, but I don't. So negative 0.946x plus 70. But it's important that you recognize that you can't just bring the square inside. That's illegal math. I like to stack my equal signs. Maybe I need to bring this one over. There. Expanding this, right, or feeding your chickens or whatever you want to call it. Don't forget about the x squared in the front plus. I'm going to do big brackets around just because then if I am foiling this out and I get a negative, then I'll remember to, right, to keep that. It'd be even more of a problem if this was a negative, but let's just put a big bracket around here to show that I haven't distributed the plus inside yet. Okay. So negative 0.946x times negative 0.946x, negative 0.946 to the power of 2, whoops, negative, let me try again, negative 0.946 squared is, I'm going to round to 3 decimal places again. I know, naughty. 0.895x squared. Hey, not negative. I just forgot to put brackets around. Negative 0.946 brackets squared. 0.894916, but I'm just gonna lob it off. Negative 0.946x times 70 puts me at, oops, negative 66.22x. Same thing again, different order. So minus 66.22x, and then 70 times 70 is 4,900 equals 2809. Big bracket. Can collect like terms here. now that I have these brackets, I can just scan this and see, okay, the plus would spread inside here and it wouldn't change anything. So then I can rewrite it without brackets, but also I can collect 1x squared plus 0.895x squared, right? And negative 66.22x minus 66.22x. So I can collect these like terms. And so let me just show x squared plus 0.895x squared plus negative 66.22x minus 66.22x plus 4,900, bless you. And maybe in the same move, I'll bring this 2809 over to the left-hand side and set it equal to 0. Because in order for the quadratic formula to work, we have to have the quadratic set equal to 0. Oops. 2809 equals 0. I'll highlight this because that kind of came out of nowhere. Not really, but okay. Here we get 1.895x squared and negative 66.22 minus 66.22 is minus 132.44x, and then 4,900 minus 2809, oops, 2809. I get plus 2,091 is equal to 0. Now, right, we've reached our goal of a quadratic equal to 0. A is 1.895, B is negative 132.44, and C is 2,091. So X is negative B, negative 132. Oh, you know what? Sloppy Emily. Negative B plus minus the square root of B squared minus 4AC over 2A. Negative 132.44 plus minus the square root of negative 132.44, but you want to make sure that's wrapped up in brackets, right? Because then otherwise you won't get rid of the negative. Minus 4 times A, which is 1.895, times C, which is 2,091. Divided by 2 times 1.895. Nice and slow under that square root, right? And so we've got 32.44 squared. Usually when I enter it in my calculator, if I'm squaring a negative number, I usually just drop the negative because I know it doesn't have to be there anyways, or it won't be there. Minus bracket 4 times 1.895 times 2,091. So I get X is 132.44 plus minus the square root of 1,690.5736. Divided by 2 times 1.895. Divided by 3.79. I am gonna run that square root just one more time, just to make sure I didn't do it in a weird way. 132.44 squared minus bracket 4 times 1.895. If you square root that, and we get x is 132.44 plus minus 41 point, let's do 117 to 3 decimal places. Been rounding all over the place anyways. Who cares? For this one, it's more about the procedure, right, that I care about. And as best as I can, I'll make sure they're relatively nice numbers. But as long as you keep about 3 decimal places, that's fine. Okay. We're going to get 2 numbers, which is what we expected. Right? And so we get 132.44 minus 41.117 divided by 3.79. X is, let's just do roughly 24.096. And 132.44 plus 41.117 divided by 3.79 up to roughly 45.793 to 3 decimal places. Nice. So if I just snag this, well, I guess you can't see what I'm doing. Sorry. I should change it. Just let me paste this here. What did we find just now? We found that this value of x is at roughly 24.096, and we found that this value of x is at roughly 45.793. Checks out, right? Should be less than 53 because the radius is 53 all around, right? And so this 24 is less than 53 and 45 is less than 53. Beyond that, and they're both positive, so that's nice. Right? And so it all kind of checks out here. Now what? Now we need to find the y coordinates, right? To find this distance, we're going to use a squared plus b squared equals c squared, right? Or you can use the distance formula, which is just the Pythagorean formula reworked, right? With the square root already taken into account. But either way, you're going to need the y values that make this happen. Got 2 options. You can plug in each of these values of x into the circle and solve for y. That's harder than just plugging it into the line, right? They have to be the same because this is where the 2 points, or this point, satisfies both the circle and the line. So I would say let's use the line instead. So now find the y coordinates at x equals 24.096 and x equals 45.793. using either the line or the circle, you should find, we've done some rounding, we've done a lot of rounding along the way, but roughly you should find the same values, right? And so now y is negative 0.946x plus 70. I'm going to use the line, which was good. Make sure I don't use the wrong. I'm going to use the line. I'll highlight that. So then at x equals 24.096, y is negative 0.946 times 24.096 plus 70. Negative 0.946 times 24.096 plus 70. So y is at 47.205 to 3 decimal places. Which, if we map to here, right, my line's not really straight, but you get the idea. This is at 47.205. Now, at x equals 45.793, y is negative 0.946 times 45.793 plus 70. Here we go. Negative 0.946 times 45.793 plus 70. I get a y, and it makes sense that this y is less than the other y, right? 26.68 once I round 80 properly to 3 decimal places. Which means that this little guy is at 26.680. However you want to find these lengths, right, is fine by me. Let's do it in orange, finding that distance. Is there a better color I haven't used? Not really. Just red. Find the distance between the points. Between the points 24.096 and 47.205. And when x is 45.793 up to 26.680. Instead of trying to figure out the distances of A and B and then solving for C, how about we just go to the formula sheet and see if we can make this distance formula work. It's doing the same thing, but it kind of cuts down on your work a little bit. Because then you can just plug in your 2 points, right? As long as you map to an x1, y1 and an x2, y2, then just kind of keep them straight in your mind. In fact, I would probably say label them x1, y1 and x2, y2. Just as with finding the slope, it doesn't matter which you use as 0.1 and 0.2 as long as you're consistent, right? With this is 0.1 and this is 0.2. So now the distance here, which is your C, if you prefer to go kind of old school with the Pythagorean theorem, right? Then you've made a triangle and you're finding A, B, square them both, add them up, take the square root, and that's C, right? And so if you prefer that way, that's fine. But this cuts down on the thinking of the distances of A and B, especially if you're in the negative quadrant. So x2 is 45.793 minus x1, which is 24.096. Square that, plus y2 is 26.680 minus y1, which is 47.205 squared, and then don't forget that square root. And again, I'm going to break down the subtraction. I'm going to square it and then just break it down into a couple of steps. If you want to skip to the end, that's fine. In your work, you don't have to show it all. 45.793. But if you want part marks, if you did something wrong along the way, the only way to get that is by showing your work. 470.7598. Just go all the way. 26.68 minus 47.205. Squared drops the negative, right? 421.275625. And then don't forget that square root. It's going to be the square root of 892.035434. $29.86696.225 is the distance between those 2 points. We have to hold our breath for 29.87 miles. Yeah. How about if you drive, I was going to do kilometers per hour, but I don't know miles. At 50 miles per hour, how long will you have radio transmission, right? Then it's exactly the same as the ant problem. Here, this is the end of the problem, right? This is how long we have transmission for. But let's just take it a step further. If you drive at 50 miles per hour, how long will you have radio for? Maybe you slow down in the radio zone. So the distance, 29 point, let's say 87 miles. And the speed is 50 miles per hour. I expect it to be less than an hour, right? And so Oh, but we forgot to check our answer here. Oh, I guess we don't have the distances explicitly. Sorry, forget that. Forget I said it. This distance should be longer than A and B, right? And so for how long, we have the distance divided by the speed, 29.87 miles divided by 50 miles per hour. To keep it on the same page, I'll do it here, 1 hour per 50 miles. So 29.87 divided by 50, 0.5974 hours times 60 minutes, just to show off, I guess. Approximately 36 minutes. There's another one just like it in the textbook. What? There's a textbook? Yeah, I know, right? There's even more like it, but these were kind of more complicated than what I would kind of get you to do. And so, but there's another radio transmitter just waiting for you to chip away at it. Well, the original answer was just the distance, right? But then 0.5974 hours, which if you multiply by 60 is approximately 36 minutes. Nice. So we're the ant. Other than that, it's the same. I think I didn't have an ant problem. I think I have one of these in that practice that I posted. Yeah, but they're the same. But I like the ant one because it's so cute. Any questions about this one? No. Anything else you want to go through? Or you want to study for whatever it is you have next? Seems like there's something important happening next.
Yes. No. Talk.
Well, we can keep going if you guys have questions to work through, or you can study for whatever it is that's happening. You got it. I'll be around. I have an exam in the morning the day before our test, but I'll be around after noon on the Monday, because we're on the Tuesday, right? And obviously you can always message me, but I won't be in town over the weekend, so it'll have to be on Zoom or message. And with that, anticlimactically, we're done. Good job. We've still got the final exam and it's the final week, so everything's stressful, but good work. All right, I'll stop this and I release you early crazy.